Hello, everybody. My name is Rafael. Welcome to Rebuild with PG, where we talk about a big industry here in South Florida, concrete restoration. With me today, I have some very important guests, and I'd like for them to introduce themselves.
Yes, hello everyone. My name is Francisco Gracia. I am a registered professional engineer in the state of Florida, currently working in the industry. In the topic that we're going to be discussing today, uh, we work for the Falcon Group, and to my left we have.
Yeah, Daniel ACOSTA. I'm a structural engineer as well, graduated in Cuba 2019. And I just recently passed my FE exam, which I'm very proud of, and working on the restoration since 2 years. We are in Falcon for 2 years, and exciting to be here.
All right. Well, congratulations on passing the exam,
Oh
first of all.
yeah,
All
that's
right.
a
That's a
good
big
one.
milestone.
Yeah.
Well, for those of us who've seen our previous videos, we talk a lot about what our process is. As you know, the engineers, you guys are hired directly by the associations, by the condominium, by the client, basically. What we would consider our client, they hire you directly, so you work directly for them. We work alongside with you and them. You guys set up the specifications, but we've worked together a lot. As you know, there's always the issue with money.
Mhm.
With a job, you can have a runaway effect where a bunch of change orders come in,
Yeah.
the job gets a lot bigger than really meant to be, especially when you have like these lower 50, 60 to like $100,000 jobs. They usually double or
Yup.
triple in some cases. So I wanted to ask you guys so that the audience knows why that is. Why do you think it's important for the client to follow your recommendations, especially when it comes to the quantities? When you tell them, hey, we need to continue on, we need to do more of this, regardless of the additional cost, what would you say to them?
You can go.
Okay, so I think it's important to understand the process in which we develop the scope of work for the work to be done, which then translate into a dollar value that the association needs to prepare to pay. So I think the process in which this information is generated is very important to understand. So when we go out there and your property has to do some work, obviously we rely on a couple of primary things: availability of plans, availability of the history of the building, and as well, we will be conducting what we call an assessment where we walk the property and we collect some information, some data, which then we will use and extrapolate depending on the level of accessibility and visibility we have during that phase. Now, obviously, experience comes into play a lot because the more you deal with experienced in the sector and in the actual area, we know the type of buildings, their typical behaviors. So we have a lot of the history and data collected as to how these buildings actually age, deteriorate, and then therefore we can make that correlation to kind of give you a scope of work that is as close as possible to what we're going to be finding when we do the construction, but it is not an exact science, unfortunately. So there is that possibility of fluctuation between what we have set up and what we're going to find once the construction process starts. So I think there is a margin there. When we do the assessment and we put the project together, we always recommend the association to have an extra layer of finance, like a financial contingency of amount, but that's not automatically translated to the scope of work at the beginning of the process.
So they would have
Yeah.
not only the amount to pay for the project, but a little bit extra
Extra.
in case there's some kind of contingency we need to go over. All right,
And
now.
also what happened is that sometimes we have a quantity leftovers that we don't use because we estimate. Of course, we do an assessment based on observation and based on sounding, and sometimes we don't get the accurate 100%. And we sometimes, like, we are having projects that we are anticipating to do concrete repairs, and then the concrete was good in some areas, or the extension of the damage was not significant. So the client also have a leftover quantities in some of the items that we put on.
So let me ask you something, and then I've never done inspections with an engineering company. So when, let's say, you have a building that has 100 balconies, something like that, you go and maybe you inspect like one in every four, one in every five, so about 20, 25%, maybe 30% at
Mhm.
most of all the balconies. I understand that you guys probably bill by the hour. In most cases, a lot of engineering companies would. So you can't inspect 100% of the building, which is be far too time consuming and costly for the client. would you say if you were to inspect every single balcony, if that were available to you, would you think, in your experience, the additional cost of time that you have to build them for that inspection, would they save that later on in having a more accurate, I guess, bid or estimate, or do you think they'd still have the same cost overruns?
I think it's hard to. That's a very difficult question
Yeah,
to answer.
very difficult one. Yeah.
But I'll say this. I think this approach is. I'm going to say it's a business decision. We have a minimum amount of units that we would like to have to collect. Basically, that gives us a sample of the building that we're going to use this information to extrapolate. Right. Basically, extrapolate meaning that we take it. We take these samples and we say, we saw 3 units. This is what we collected. The building has 10, so therefore, if you find this amount for 3, then you should have this amount for 10. It's a direct correlation there. However, the more units we inspect, the more the more we're able to reduce that gap in inaccuracy, right? So we'll become more accurate. But you are correct, right? Why would you inspect 100% and what are you actually gaining? So I would say the advantage of inspecting, because we do have some associations that say, hey, listen, we want you to put your eyes on every single crevice before we start. That's when the association wants to take a very, very clear financial perspective of what's going to happen. And that's the extent to which we can give it. And we can put in a few locations some destructive investigations, but we kind of reduce that gap. So I would say, to answer your question, that approach is basically a business decision that the association will take because they want to be very, very clear and kind of reduce the amount of fluctuations that they may have, as far as the dollar value that they're expecting to do the work. So once they want to be as accurate as possible, they can request that.
Yeah, but we have to bear in mind as well that doesn't mean that we have 100% accurate, because sometimes when you discover the areas, once you start shipping, you're going to see the real extension of the damages.
Right.
And sometimes you have a very good building, okay, but sometimes even if it doesn't look bad, when you start shipping, you're going to notice a lot of damages, corrosion extension, reverse section loss. So you can anticipate, yes, you're going to have a more accurate assessment, yes, but not 100% you're going to target everything.
Right.
And if I may add as well, I think it's important to understand that although we're calling it concrete restoration, there is a very important link with forensic engineering. Meaning, and I'm not going to go into that because that's going to maybe it's a different topic, but what I'm trying to get at is when we don't see those typical damages during the process of construction, once you open it up, the nature, the source, or the cause of the issue may be more than something superficial. It may be an underlying issue where your engineer, we hope that your engineer is knowledgeable to be able to see the issue, somewhat like a rash, if I can put it, like make an analogy. It's kind of a rash. So obviously a rash, sometimes you can just on the surface treat it, but sometimes it's an underlying situation, an underlying condition that you want your engineer to be able to go deep into that from a forensic level and actually address the issue at its core. So there's kind of that as well. And to circle back to the association perspective, then yes, that will have an impact on the cost.
Right.
Yeah.
Right? Because at the beginning you start at it very superficial, but now you're looking at something much deeper, right? So that also kind of impacts the cost.
So it's similar to how like a doctor would take a look at certain symptoms, put it all together, and give you like a more in-depth diagnosis once they delve deeper into it. Like this is what's
Precisely.
really causing your issues here.
And one of the things I think is important, and anyone in the industry, I think it's important to try to use as much as possible analogies with the medical field, like your visits to the doctor, everything that is happening as far as the building, rather it be restoration, 40-year recertification, 25-year milestone, these things, a very easy approach for people to understand, for layman's term, basically, is to kind of bring it closer to visiting your doctor and kind of make that correlation.
It's
right?
like your
With-
daily checkup.
yeah,
Yeah.
and it's
That
and
would
it,
be
and
like
it
that. Or
makes them
yearly.
really understand what's going
Right.
on and what you're doing. So we're essentially primary physicians for the
For
building.
building.
Yeah.
And building
Very
doctors.
true.
All
Building
right.
doctors, right. But we're not
That's a
specialists,
good
right?
one.
So it's important. We're not necessarily specialists. Not necessarily, because sometimes you have your cardiologists, you have your, so it's kind of like the same approach. We come in general, we understand what's going on. In-house ourselves at Falcon, we have a lot of specialists, if I can put it that way.
Okay.
But it's important to understand that you may need further tests in certain specific departments with specialties. It's the same thing as a doctor approach.
Someone like an electrical engineer specialist,
Yeah,
something
Yeah.
of that nature,
correct,
MEP.
correct,
Okay,
correct.
so all right. Now, what would you say are some of the biggest factors that cause an overage in quantities? So, what are some of the underlying conditions that usually cause overages beyond what you may estimate, what you may see just on the surface?
Do you want an example or
Well,
what
I
would
mean,
be the?
so one of the things that we've touched on before on this show is when we open
Sorry.
up the rebar, when we open up the concrete, we look at the rebar. We
Mhm.
usually have what, like 6 to 8 inches of clean rebar
Mhm.
before we're good to close it up,
Yeah.
right? And a lot of times you'll see the rebar still corroded inside the concrete, but you test it, it sounds good.
Yeah.
You
Right,
have a corroded rebar, but it sounds good. And you know that eventually it's only a matter of time before that expands enough.
Expense.
So a lot of times, from you or other engineers, we get the directive to expand even more beyond the area that was just sounded. So that's one example.
right.
Like, what other examples do you know of that could cause an overage beyond the initial drawing that you make? Here's where you have to chip.
Waterproofing on housekeeping pads or topping slabs.
Mhm.
Because sometimes when we arrive to a job site, we have a waterproofing project. We notice that the waterproofing was installed on the topping slab and not on the structural one. So now we have to include on the bid or include the demolition of the entire topping slab. In the beginning, we thought that we just remove the membrane and apply a new one. So that's a typical one. That's a very
Yeah.
common issue that we face every day.
And to that, I'll probably add, I'll say it would be essentially underlying conditions. I think that's the
Mhm.
biggest element that causes what they call scope creep,
Mm-hmm.
right? So I'll just to give an example, right? Doing a repair in a PT building, you may find yourself where the repair, the underlying condition causes you to not only no longer have to work at the slab edge level, but now you're dealing with the railings
Mhm.
because your repair impacts the railings.
Mm-hmm.
Sometimes they go into the apartment. You have to deal with the sliding glass door issue. You have to deal with the interior finishes in order to repair an element that is damaged that you saw essentially at the slab edge level.
Yeah.
So I would say overall it's underlying situation, underlying conditions that unfortunately in the assessment process is very hard, very, very hard
Not
to
see it.
catch,
Yeah.
right? And I'm going to say also that there's a group of repairs, typical repairs, that fall in what they call an allowance, right? And what happens is we expect for a repair to happen, let's call it, just for example sake, slab edge repair, and then you have different repairs that are full depth repairs, partial depth repairs. So you have some kind of a wash, for lack of better terms, where you go over on the a full depth repair and a little bit less on the slab edge because they're all concrete repairs essentially
Right.
at different unit costs because the involvement from the contractor standpoint is different. So you have different unit price value for it. But essentially the overall repair work kind of shifts from one silo to the other because as you're chasing the repair, the underlying conditions, it may shift in nature. So I think those are the things that create a little bit of fluctuation from what we originally thought that we were going to have at the beginning.
I would like to bring an example as well.
Generic commercial building.
Remember, it's a building that we have a waterproofing replacement, the membrane, and we assume, we anticipate that the damages are going to be related to the concrete slab.
Mhm.
So, in an observation, we have a all membrane on top, so we cannot tackle or we cannot see any further damage that the slab has. And now that we discover the area, we remove the all membrane, we notice that the concrete is in very good shape, but we have a lot of structural cracks because we don't have enough expansion joints. So the slab is moving a lot, and we have a huge cracks causing the leaks on the
Got it.
garage. So there's something that we couldn't tackle because we have the membrane, the all membrane on top, and now we have a lot of structural cracks that are not covered in the bead form. So that's a
So now that you mentioned the expansion joints, we're not adding any expansion joints in that project. We're just removing, replacing the current ones. Would you recommend then adding more expansion joints? And if we don't, do you expect to see those same cracks in a few years?
I don't think so because I noticed that they hired engineer before and there is a lot of crack gauges and they're keeping monitoring and I noticed that the cracks are not moving at all. So I think that the building moved whatever that
It
needs
moved
to
what it was going to
move what
move.
is going to move.
Okay.
That's correct. And now we don't have to include any another expansion joint. And and I think that the reason is also that we have a PT slab, so we don't want to deal with PT slab
Yeah,
repair
started cutting
increase.
through, hit
Yeah,
a
cutting through
cable.
Right.
PT. No, 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 no.
So, I'm sorry,
I
go
was
ahead.
going to say the expansion joint, if it's a construction expansion joint, this is usually, taken into account at the original design
Right.
aspect. So it's very rarely, and I've never seen it, and I don't think that it really happens where you come in and you actually create a new expansion joint because that
Yeah,
will change the overall behavior
yeah.
and the
Right.
original
Hmm.
intent of how the building was supposed to behave. And I think that's kind of probably a far-fetched one, but I think creating some type of I would say cuts,
Control,
control
control
joints, and,
joints.
and, and basically non-structural elements can help control these cracks, but not at the structural level, but some added elements.
Now you mentioned the PT cable. So one thing that I've always been curious about is we've worked in buildings with PT cables by the beach, inland. We worked with buildings that have no PT cables by the beach and inland. So is there a benefit of using PT cables? Why would you use PT cables instead of just straight rebar throughout the building? Can you delve into that a little bit?
Sure. So one of the biggest advantages of using PT cable is at the development stage when they're building, right? What this allows you to do by using PTs, it allows you to keep your slab that separates from floor to floor as thin as possible. When you don't have a PT cable, you end up you have to incorporate beams, and they kind of impact your vertical clearance of every unit. So essentially, from a larger scale standpoint, you're able to stack in more floors, right? When you have a PT than if you have standard reinforced concrete, because you have to not only create space for the thickness of the slab, then you need to give it its adequate beams that cross into the space.
Intermediate support as well.
Right. So you kind of have, just to give you an example, right? If you have a building that has an 8-inch thick slab and then you have a 16-inch beam below it, there's 16 inches that you're losing over 20 floors. You're
Yes.
losing, you could potentially be losing a full floor.
Yes.
Right.
Right.
So the idea is to do that. And from an aesthetic standpoint, again, they have like open floors and less interruptions. You're able to see, from slab to slab, and it gives a lot more space to maneuver from at the development stage. So this is pretty much the reason why you're seeing buildings with PT. Is that added value from
So
a space
saving
standpoint.
money on concrete.
Right. Well, I would have to look into it if there is an offset because you're replacing the concrete by the PT, which requires a different skill set, a different set of materials. But I think overall, the developer is selling square footage,
I see.
right? The
Yeah, 'cause
developer
you may be able to squeeze in a floor too,
Yeah.
especially if you've
Correct.
got taller and taller and taller
Correct.
buildings.
So the advantage is
Right.
incredible, right? And you can have better clearance and the floors themselves, have tall ceiling units, and etc. And not to include, MEP, your AC system running
Now it has
through.
more space.
You have
More
clearance.
space.
You can have more
Clearance.
optimum design. You're not dealing with challenges as far as conflicts with the beam, conflicting things of that nature because it's clear. So there are a lot of advantages there from an original design standpoint.
Okay.
You're right.
That's nice. So now that I have you guys here, one thing that we always come across when we're doing the buildings on balconies is you have these owners, they put in these beautiful tiles on their balconies, and then we have to come by and rip it all up. They always get mad. We feel bad because they just remodel. We always have the bad luck. We this guy just remodeled 3 months ago or
Right.
something like that. But
a
one
tough
thing
one.
we always tell the associations, like, look, whenever we put in, especially like the most prevalent waterproofing system, we use 715, 735, or 710, 715, 735 for like the balcony waterproofing.
Right.
We tell them don't put tile back on, right? So you as an engineer can you explain why an owner would not want to put tile back on, or maybe what other systems are out there, what conditions would allow an owner to have some kind of overburden on their balcony?
I would say it goes back to underlying conditions. You want to be able to see what's going on, right? If you have something going on below a tile, you have no idea what's going on. You don't know the extent of the repair. And obviously, you don't have the opportunity in a timely manner to address it because it's under a tile. So when you put a waterproofing, it allows us to have kind of a direct visual on the slab itself, all while protecting it. So we always recommend that. The tile, we understand the advantages of the tile. It's great value from a real estate standpoint, but that's the compromise because of the laws. When we have to come in as engineers and say that this is safe, at a minimum, I need to see what's going on.
Of course.
At a minimum, right? So I think that's where there's a bit of a conflict there, and unfortunately, because of the requirements of the law, because of the needs to pass the laws and the 40-year recertification of the repairs, then we're forced to, unfortunately, having to remove these styles so we can get eyes on it and be able to sign off on that. So I think that that's definitely an issue where there's always going to be kind of a disagreement, but overall we need to at a minimum see what's going on, and we prefer the approach of always being able to see, and continuous monitoring and maintenance and things of that nature we want to see. So that's essentially what it is.
In the topic of continuous monitoring, we've come across some materials I'm sure you've heard of it, not the electrostatic, but that kind of electrically conductive paint
Yes.
that you can apply over slabs, and then you connect like special nodes to the rebar itself, and it helps monitor the corrosion levels over years on the rebar. Are there any other technologies that help you with continuous monitoring other than just a destructive test, or GPR? What other kind of methods do you use to monitor the building in that manner?
So I think the old school way is probably the best way. And
I would go
right,
say that.
right. So the reason why is again, you're probably gonna explore the option of using these systems that monitor the level of corrosion of the reinforcement, depending on the condition of the building and the accessibility it depends on the building, right? Some buildings that might be the best value for you, but in general, visual observation and routine crack monitoring, being aware and conscious of what's going on in your building is probably your best indicator, because that's the great thing about elements, right? They show you signs.
Yeah.
Unlike glass, right? So it's not necessarily a brittle, like overall the reinforced concrete system is not brittle. It doesn't just shatter like glass.
Right.
Right? So it gives you signs. It shows you things. And
Do you remember the
Other generic.
project that we noticed visible? You can see it from the first
Right.
floor. You can see the deflection on the balcony.
Right.
Yeah, that's
So
another.
you could see it gives you signs, basically, not to say it's probably screams at you, right? It screams at you and say, hey, listen, there's something going on. And usually it gives you enough time to react. The question is, does the association pay attention to it? Do they have someone that looks into that? And unfortunately, the incident that happened in Champlain Tower kind of raised all the alarms now. But the idea is it kind of tells you, right? It gives you enough signs, and you just have to pay attention to them. So that's why we recommend visibility. We want to be able to see it and have people see it as often as possible.
Well, after the Champlain Towers, we know that the especially like the city governments have been a little bit more. They've been hammering really associations to have that savings that we're talking about, to have those
Rectification.
funds that they need to have, and to start. They've really been pushing those recertifications. Have you, as engineers, have you guys been imposed like stricter codes, stricter regulations after the incident, or is it more or less just on the association side?
I would say a little bit of both, because we're on the same boat, I would say. It's not like we separate the problems. Once we come in, we're basically with the client to get the project where it needs to be. So I wouldn't present it that way. It's a combined issue, because the requirements that now are being imposed, we have to accompany the association with them. So it's kind of our problems as well, right?
Of course.
Rather it be from the money that they need to put aside and the situation in which they find themselves. So we kind of, I would say it's the same things for both of us. From the, I would say the biggest impact is the time. Now you need to have these things done at a specific point, and you need to have certain amount of funds there. We're in there with them, basically.
Right. Well, because they said that they hire you guys. You guys are building doctors. You go
Yeah,
in, try to
right.
find these diagnoses. But it's an interesting field in civil engineering. And you guys have specialists, so you said, that work for you, whether an MEP type of engineer. Besides MEP and the civil engineer, any other kind of specialists that you use on a semi-regular basis?
So Yes, I would say so. I would say yes. They work with us because I'm more of a structural background slash construction background.
Okay.
Danielle as well is kind of like me. We kind of have the same profile.
Yeah.
We have some overseas experience where there's not a separation there. So I think we believe that's what gives us our added value when we work, because we get closer to the ability to do the work, right? To get the work done, not necessarily turn in a piece of paper and say this should work,
Yeah.
Right.
Well, so that's how we kind of we understand each other in
Yeah.
that sense.
Yeah.
But yes, as far as specialist, I would say when we're doing all these envelope assessments, I would say we start off with roof consultants for moisture surveys. Manufacturers get involved as well with us, but internally, I would say mechanical, electrical, plumbing. Falcon Group also provides support as far as we have garage specialists. We have civil, or usually people confuse civil and structural. Civil has to do a lot with
Water
pavement,
treatment.
water, and things of that nature. That's also a specialty. I would say to a certain degree, what happens below ground, they get involved as well. So there's a lot of collaboration there. But at the end of the day, these specialists need to work as a unit. It's kind of like a team. Everybody has their position, but the team needs to move as a unit. So that's pretty much the way it works. Pretty sure there's more, but those are the
Yeah.
ones that come to mind.
Well, when we have us as a contractor, when we have a project that involves other specialties, like you said, plumbing, electrical, whatnot, we hire, obviously, we are electricians, plumbers, roofers in certain cases. At the end of the day, it's the GC, the general contractor, that basically envelops everybody. They're leading the charge and they're using these support roles to push the project forward. Is it the same way in the engineering realm where you have like one specific engineering firm or discipline that's kind of taking over the project as a whole and then using these specialists to
Jump
fill
in.
gaps in knowledge?
So I would say it's very similar to the GC, with the exception that I would say the engineering firm would be self-perform, right? It's like saying you're a general contractor and you have all of these other subcontractors,
Right.
but they're in-house.
Okay.
It's pretty much the same,
All right.
right? They're all in-house.
Well, thank you very much,
All right.
gentlemen.
All right.
This has been very helpful, and that's the time we have today. We'll catch you guys on the next episode of Rebuild of PG. Have a great day.
Thank you for having
Thank you.
us. Thank you.